Okay, let's go. Let me help you with the second assignment of algebra. It has 10 questions. First, in algebra, we'll use symbols and letters to represent actual numbers. Is that true or false? Well, this is true. So the core, the essential of algebra is that we are going to switch to symbols and letters instead of just the actual numbers. That means we're going to use X, Y, or A, or B, or M, or N. And you will see these are super powerful tools that can help us to deal with more difficult questions. So yes, we will use symbols and letters. And second, which one is an example of algebraic thinking? Algebraic thinking, right? So as we say previously, we are more used to, just matching numbers. Matching numbers. Say, I tell you if a number plus 6 is 13. So traditionally we'll try, some students they try, they say 1 plus 6 is 7, no, 2 plus 6 is 8, 3 plus 6 is 9, 4 plus 6 is 10, and then 5 plus 6 is 11, 6 plus 6 is 12, and 7 plus 6 is 13. Therefore, I got the answer. It's 7. Yeah, that's right. That's right. But when we get to harder, we get to more difficult questions, like say, just simply if I change this question a little bit, let's say a number plus 16.7 will give you 293.1. And it becomes harder, right? It becomes harder for you just to try and match. And that's when we will need to use algebraic thinking. We will need to use letters and symbols. So here, by using algebraic thinking, we'll say, okay, this number, I will use a letter. Let's say x. X plus 16.7 equals to this number. I don't know what is x, but it doesn't matter. It doesn't matter. I just need to do one more step. And I can find out the answer. We will explain in more details about how we solve the equations, but I want you to see immediately the power of algebraic thinking. So algebraic thinking, we need to use letters and symbols. Next, if there are a total of Z ducks on the farm, how many total legs will there be? So we have this many ducks and we are looking for the total legs. Okay, this is quite funny question. So maybe we can take a look at the ducks. So here we have the ducks, right? And as you can obviously see, how many legs does a duck have? Wow, 2 legs, right? 2 legs. So this one duck, 2 legs, 2 legs, 2 legs, 2 legs. And see if we have more ducks. Let's say if we have more ducks. See here. Scroll down a little bit. Okay, see here. This is a good picture. 5 ducks. Now how many legs? Maybe you can count 10 legs, right? So if we have 1 duck, that means 2 legs. So this is our ducks, this is our legs. 2 duck, 4 legs. 3 duck, 6 legs. 4 duck, 8 legs. And you can see the relation. The legs is always double the number of the ducks because each duck has 2 legs. So the legs is always double the number of ducks. And then when we have Z ducks, that is when we have Z ducks, the legs should be double of that Z, and that will be 2 times Z, 2 times Z. Because that's a relationship. we are finding out the relationship between the number of ducks and the number of legs. So the total legs will be 2 times z. And why we are doing this is we are going to use this to help us to represent something we don't know yet. We don't know the legs, but we know the legs is gonna be 2 times z. 2 times z. Okay? Good. Let's go on. Which one correctly represents this situation? Think of a number, double it, and then add 10. Okay. Think of a number. Okay. Again, this is something that's totally undecided, undetermined. Well, you think of a number. I don't know. I don't know that, right? That's a question. But double this and then add 10. Okay. If this to start with, I don't even know this answer. How can I double? How can I don't know, it's a 5 or 6. How can I double that? So this is when we need to use algebraic thinking. We don't know this, but we will use a letter to represent this number. Whatever this number is, we use a letter to represent. Let's use the letter X. Okay, let's say X is a number you are thinking. X is a number you have in your mind. Double that. Double means the x times by 2. That's double, right? That's double. And then add 10. Based on this, we add 10. It's going to be plus 10. See? We have a number. We use a letter. And then we double the letter. And then we add 10 on top of the 2x we had. So we can represent this whole process using 2x plus 10, and that's going to be this one. If Abby bought a dozen of cupcakes for $9.60, which one correctly represents the price of one cupcake X in dollars? So here we have a dozen cupcakes. That's 12, right? 12 cupcakes for $9.60. And which one can represent the price of one cupcake? So let's take a look at these two options. So 12 times X. We know X is the unit price. And the 12 is 12 pieces. Right, the 12 pieces, and that's $9.60. So this is basically telling us 12 pieces times by the unit price, the total price is $9.60. This seems to be, telling us what's happening here. So this actually represents the situation. You got 12 cupcakes, and multiplied by the unit price, the total price is $9.60. And this one 9.6, that's a total price, right? Total price $9.60. Plus we know X is the unit price. And the 12 is how many units? Like a dozen. Number of pieces. Okay, so it doesn't make any sense. The total price plus a unit price, how can it should be another price, right? But here it's become the number of pieces. So this one doesn't make sense. This one doesn't make sense. So we understand the symbol and what do they represent. We can read the equation. Therefore, our answer should be, I think you know what is that, should be this one. Next, if Mike is Q years old, Jill is 8 years older than Mike, which one correctly represents Jill's age? So again, Mike, he is Q years old. Jill, okay, we don't know how old is Jill. Jill is 8 years older. So let's imagine if Mike is 1, Jill will be 8 years older, be 9. If Mike is 2 years old, Jill will be 10 years old. If Mike is 3, Jill will be 11 years old, right? And so Jill's age is always equals to Mike plus 8, plus 8, plus 8. Therefore, when Mike is Q years old, Jill will be Q plus 8 years old. Q plus 8 years old. Jill is always 8 more than the age of Mike. So our answer should be Q plus 8. And if a car moves at a speed of y miles per hour, which one can show the distance if it travels over 6 hours? Okay, see here we are getting to a problem that we might encounter. A car moves at speed of y miles per hour. Which one show the distance over 6 hours? So let's say for 1 hour, how many miles? This is time. This is distance, right? Okay, let's write down. For 1 hour, how many distance? What is the distance? The distance will be y, right? We don't know how much is that, but we know it's y miles per hour. Therefore, for 1 hour, distance will be, y miles. Because the speed is y miles per hour, y miles over 1 hour. Then what happens if 2 hours? 2 hours, he should have, based on the first hour, y miles, and then he should have another y miles, right? Or we say we can write it as that is 2 times y, 2 times y. 2 hours, 2 times y. And 3 hours, okay, based on this 2y, then you should travel another additional y miles in this third hour. Or in other words, we can write it as 3 times y. I think you can see what's happening here. For each hour, there will be y miles. So 1 hour, we can write this as 1 times y. Okay, 1 y miles. 2 hours, 2 y miles. 3 hours, 3 y miles. And we can, I think it's safe to say, 4 hours, we are going to have 4 y miles. Because 3y times 1 additional y miles, that's 4y miles. And 5 hours, 5y. And 6 hours, 6y. So we can read it, it's going to be 6 times y or y times 6, right? 6 times y is the same as y times 6. So over 6 hours, the car travels y times 6 miles. If the length of a rectangle is L inches and the width is 3 inches less than the length, which one can correctly represent the width? So we are dealing with a rectangle. Let's draw a rectangle. You know, it's always helpful to draw something to help you. The length, this is a length. L inches, we don't know how long is that, right? This is L, but we know this is L. This is L. And the width is 3 inches less than the length. So the width is 3 inches less. 3 inches less, but we don't know the L. We don't know the L. But we know it's 3 less than. So remember, if this is, let's suppose for the L and W, suppose the length is 10, the width is 3 inches less, the width is 7. If the length is 11, the width will be 8. If the length is 12, the width will be 9. If the length is 13, the width will be 10. And I think you can see the pattern here. The pattern is always subtract 3, subtract 3, subtract 3, and subtract 3, right? And we can say from L length to the width is always subtract 3. It's always subtract 3 because 3 inches less. Therefore, L subtract 3 will be W. L subtract 3 will be W. Length subtract 3 will be the width. So the width is L subtract 3. L subtract 3. That's the answer. That's the answer. So even though we don't know how long is that, we can actually deal with the unknown things. We can deal with the unknown things. That's a power of algebra. It enables us to deal with unknown things. Let's go on. Which one correctly represents this situation if you multiply me by 3? Okay, very funny. If you multiply me by 3 and increase that value by 5, I am 35. Okay, this is funny riddle. Probably you can do it, play it with your friends. And what is me? What is me? So again, we don't know this, right? We don't know this. We don't know what is me. But you know, in algebra, when we have something not known yet, we use a letter, we use a symbol for that. Okay, let's just use a letter for this, x. We say this is x. And you multiply x by 3. What happens? You multiply x by 3. It's going to become 3x, right? Multiply x by 3. That's going to be 3x. Increase that value by 5. That means you will add 5, right? Increase based on the result of 3x, you plus 5. That's increase the value by 5. Increase the value by 5. And I am 35. That means after you do all this, the result is 35. The result is 35. See? That's what's happening here. We don't know this number, but we use a letter x. Then multiply me by 3, multiply x by 3, that's 3x. Increase that value, increase 3x by 5, 3x plus 5, and I am 35. The result is 35. And that's actually the first one. That's actually the first one. And you know what? I believe using the traditional matching numbers, it's going to be hard for you to find out what is me if you want to know, really want to know what is the number, what is me, what is me, what is me. And actually, by this equation, we can find out. So let me quickly show you. So, okay, we are going to talk about how to solve equations later. But let me just show you for the time being. 3x equals 35, subtract 5, and 3x is 30, x is 10, x is 10. Okay, is that true? Is that true? Maybe we can do the calculation. We say the number is 10, but let's verify. Let's verify. Okay, let's get to... Oh, by the way, everyone, let's pause for a moment and let's subscribe. Hit the subscribe button in the YouTube video. Hit subscribe. Everyone, let's do it now. Subscribe. Okay, give it a moment. Let's pause and subscribe. All right, let's go on. So we say x is 10, right? And we say that number multiply by 3 and increase by 5. So let's say 10 multiplied by 3, 30, and then increase the value by 5, 35, right? 35. That's the answer. That's the answer. We solved it without actually trying from 1, 2, 3, 4, 5 up to 10. Okay, last question. If the side length of a square is x inches and its perimeter is 60 inches, which algebraic expression can represent this situation? Okay, we're dealing with a square. Let's draw a square. Let's draw a square. Okay, a square, right? If the side length is x inches, so that means since this is a square, so that means this is x, this is x, this is x, and this is x. The perimeter is 60 inches. What is perimeter? Perimeter is all the four sides add up, right? So perimeter, I hope you remember this from your previous lessons. Perimeter is all sides, so it's four sides. It's gonna be x plus x plus x plus x, right? All sides add up, and that's 60. So that means these numbers add up will become a 60. It's a 60. It's a 60. And how can we represent this? So x plus x plus x plus x, 4x add up, and we can rewrite this as 4x, right? That's 4x add up, so it's 4x, and that's gonna be 60. That's gonna be 60. 4x is 60, and here we have that, right? 4x is 60. And after you set up this equation using the symbol, you can so easily find out what is the length of this square. So let me just show you. We will talk about this further later. All right. So I will say, okay, I divide by 4. I divide by 4. I have x is 15. X is 15. I solved it. Okay. And you can actually verify if x is 15, then the four sides will be 15, 15, 15, and 15. And you can calculate the perimeter, add them up, 15 plus 15 plus 15 plus 15, and that will be 60. So we used the algebraic thinking and we solved this problem. We find out the length of the square. So that concludes our solution for the second assignment for algebra. And before we go, take a moment, pause the video and hit the subscribe. Everyone, let's subscribe now. Okay, let's subscribe. Bye bye.